Okay, now that you've seen a video that gave you the introduction to limits, we want to find the limit as this function, f of x equals x squared minus 9 over x minus 3, as x gets closer to 3. And the notation that we'd actually use here is, we'd say we're trying to find the limit as x goes to 3 of x squared minus 9 over x minus 3. So we're saying, if we look at the graph, what happens to the y values as the x values get closer and closer to 3? And while I start my calculator, I want you to think about that. So I'm hitting the y equals button and I'm going to put in our function. So parentheses x squared minus 9, close that parentheses, divided by parentheses x minus 3. Okay, and we're going to graph it. And we're going to get with what looks like a straight line. But we have one problem. What is f of 3? Well, f of 3 means you plug 3 into the function. And that, if we're able to just plug a value into a function and we get a number out, that will be the limit. But when we try to find f of 3, that would be 3 squared minus 9 over 3 minus 3. And here's the big problem. We would be dividing by 0, and we can never, ever, ever divide by 0. So that's something we can't do. And what this calculator isn't actually showing you, let me set the window. Let's go from 2 to 3 by 0.1. Let's see if we... I should have gone a little bit further. Let's go to 3.2, I guess. And there, I just connected it. What's actually happening, but the calculator is very bad at showing, is there's a hole at 3. So in the line, we get this little skip. And if we tried to, another way you could see this, if we tried to trace it, if we said, okay, let's go, here's the x value it's on. Let's get closer and closer to 3. Okay, it actually skips 3, but if we go calc a value and we ask it what happens when x equals 3, it's not going to give us anything. It doesn't exist there. So we're going to use the table to find out what happens around it. What happens is we start at 2 and come up, so let's go back to the trace. So we could start all the way at 2 and find out the y value at 2 and 2.5. So here we're close to 2. Okay, so at 2 here we can see the y value is 5. And we'll do the rest with the table. But we're going to go up and say, okay, what is this getting closer and closer to? Now, the way I like to do the table for something like this, if you hit second and then the window button, it'll go to the table set. And I like to put the independent on ask, okay? Your lab will lead you through something slightly different, and that's okay. That's another great way of doing it. But ask will allow us to put whatever values we want in for these x. So next we want 2.5. So I'm going to put 2.5 and enter. And we see that there we get 5.5. Okay, then I'm going to do 2.9. And I'll just put them all in here. 2.99, 2.999, and 2.9999. And you're probably seeing a pattern, right? This is 5.9. This is 5.99, 5.999. and 5.9999, okay? So think for just a second about what those values are getting closer to. And now we want to do it from above 3, so starting at 4 and coming down toward 3. So we can actually go up here and just put values right over it. So we'll say 4, and then we want 3.5, and then 3.1, 3.01, 3.001, 3.0001. Okay, and so look at these values. We have 7, then 6.5, 6.1, 6.01, 6.001, and 6.0001. Okay, and if we go back to the graph, so let's go from 2 up to 4. And now you can actually just kind of see it. See this little tiny jump hole there? That's actually what's happening at 3. Okay, so let's trace this. So look at what's happening. This graph. So think of that like when the window pane example in the other video. That's maybe what you weren't able to see. But we want to know what is the y value getting close to. So as we come up this way, we can see these y values are getting closer and closer to 6. Okay, nothing, we've got a hole at 3, and then what happens after 3, it's also still very close to 6. So if we wanted to fill that y value in, our best guess, you know, kind of sometimes it's called the intended value, would be 6. And that's what we would call the limit. We would say the limit as x goes to 3 of this function f of x, x squared minus 9 over x minus 3, is equal to 6. Okay, so this is just one way to kind of explore it on our calculator and to kind of see those values getting closer, but we'll also learn ways to do it algebraically without using our calculator.